are two kinds of predictions that can be made from a regression model. And this is only relevant for the uncertainty in the predictions. The actual values for the predictions are going to be the same regardless. But when we're thinking about how to construct the uncertainty or like the confidence intervals to get the variability around predictions, we have to be careful about what type of prediction we're doing. And so the first type of prediction is when you're predicting a mean response. And so if you're predicting what an outcome will be on average, that's the first type of prediction. And the second is a prediction of a future observation. And so for an individual future observation, if you want to get a predicted value for that, that's going to be slightly different. So the actual values for both of these, the actual predictions, the predicted values, like what we just calculated in the application exercise, in both of these cases, those are going to be the same. Those are going to be exactly the same, but the variance is going to be different. And to give you a little bit of intuition as to why, if you're predicting something on average, like in this first case, there's less variability when you're thinking about an average. Versus if you're predicting something for just a single observation, there's more variability in that. And we're going to actually derive why that's going to be true in today's lecture. So, as I mentioned, this matters for estimating the uncertainty. So, an example of the first case, the mean response, is what would a chicken who eats sunflowers weigh on average? So if you wanted to know what a chicken who eats sunflowers would weigh on average, you would be using the prediction for a mean response, that first one. A second example would be, suppose you want to feed your chicken sunflowers. What will your chicken's predicted weight be? And so this is predicting a future response for an individual chicken. So that's why these two are different. In the first case, you're asking what a chicken on average who eats sunflowers will weigh. In the second case, you're trying to estimate what your particular chicken is going to weigh if it eats sunflowers. So what's the difference here? Well, the first is clearly on average, and the second has to do with individuals. So one is a prediction for an average, and one is for an individual. And as I mentioned, when we're predicting things on average, we expect that variability to be smaller than if we're predicting something for just an individual. Okay, so prediction of the mean response. So this is that example of what would your chicken who eats sunflowers weigh on average. So the prediction is going to be X transpose naught times beta. That's what we're trying to predict, and it's estimated by X transpose times beta hat. So that's what we just did in the previous application exercise. You multiply your vector of future or of values for your average chicken that you're interested in by your beta hat that you got from your model. What is the variance of this prediction? So what I want you to do now is show that the variance of X transpose time naught times beta hat is equal to this quantity, X transpose naught times X transpose X inverse, X transpose naught times sigma squared. So I want you to show that this is what the variance is equal to. I want you to show this in your application exercise, and I'm going to give you a small hint. This X transpose here, this is your X values here are fixed. So go back to what you know about variance rules, and that should help you know what you can do with that first piece. And of course, we know the variance of beta hat, so you'll be using that as well.